All right, you guys, it's Miss H again, coming to you live from the kitchen table. You guys, we're on week 7. We made it. Only a couple more lessons to go, and then this quarter is over. I'm really proud of you guys for sticking with this. I know it's been challenging to learn just through videos and to do all the quizzes, but we're at the home stretch. Just a couple more things to go. Today we just need our calculator to do some decimals, fractions, percentages, and we're going to do a couple definitions and 5 examples. So we're going to do basic probability. With basic probability, there's lots of different kind of complicated probabilities that we can learn. There's conditional probabilities. There's studying kind of independent and dependent events. We're going to keep it simple today. We're just going to go over kind of what probability is, and then we're going to look at a couple places we see it in real life, mostly with like games, like dice and cards and spinners. We're all at home. I'm hearing from so many students that they're playing more board games with their families. So it's nice that we can learn a lesson that really has to do with things we can see in our everyday life. Okay, so I'm going to do a couple definitions here. The first definition we have is something called an event. So an event in mathematics is just a set of outcomes. And then we're going to have something called a sample space, and I'm going to go over these in just a second. In a sample space, we have something that we call all possible outcomes. So in probability, what we're always trying to think is something is going to happen within a realm where many different things can happen. So we're trying to isolate one thing out of many. So the event is like the one thing we're looking for, and all of the different possibilities that could happen is the sample space. So I'm going to put our definition of probability, and then we'll kind of, again, go through these guys a little bit more. So here's our definition of probability, and really what we're doing today is something called theoretical probability, but it's just regular old probability. Okay, definition of theoretical probability. We have the probability of an event. So this P out in front means probability. Whatever is in here is the thing we're looking for. What's the chances that it's going to rain? What's the chance that I'm going to get a M&Ms when I reach into my bag of Halloween candy? Whatever this is. So we have the probability of an event is the number of outcomes in an event or of an event divided by, here's where our calculator is going to come in handy. We're going to do some division, some fractions. The number of outcomes in the sample space. So that's our definition. It's beautiful. There's a lot to think about. There's a lot of words. I kind of want to include an easy definition that I like to think about a lot. So the easy definition, the simple definition, is that the probability of something happening is just what you want to happen out of what can happen. So this is how I think about it. What we want to happen out of what can happen. What do we want to happen? We want to get some M&Ms. What can happen? There could be Snickers and all sorts of other candies in this bag. So you can look at this if you'd like. What a lovely definition. Or you can just kind of focus on the probability of something is what you want to happen divided by what can or what could happen. So let's see a definition, and let's kind of see all these words come together here. So example 1. We are going to find the probability. Actually, we've got a bag of 20 M&Ms, has 6 red M&Ms. Excuse me. So just a bag. We've got 20 M&Ms in it, 6 of them are red. Let's pretend that's our favorite. And we would like to select one red M&M. Okay, so let's go back to some of these definitions up here. You don't have to do this for every problem, but I just want us to see that the event that we're looking for is the red M&M, and the sample space that we have are all of the M&Ms. So again, you don't have to do this on your homework, but that's the event that we want to find a red M&M. This is the sample space of all of the M&Ms in the bag. Okay, so let's find the probability. We'd like to select a red M&M. So to do this, we'd say the probability of a red M&M is, again, what we want to happen over what can happen. What do we want to happen? We want a red M&M. How many red M&Ms are there? 6. Over what could happen? How many different M&Ms could we pull out of this bag? Our entire sample space of 20. So that's it for our probability. So this is what we want to happen out of what can happen. We're always going to have a fraction. With this, do we have to reduce our fractions? You know it. If you don't want to reduce a fraction by hand, you can let your calculator do it. 6 divided by 20, and then you can see a decimal. Math, enter, enter. There's our 3/10. You can also just, of course, reduce that fraction by hand. But what I want to look at is that even though this is our answer, there's a couple different possible answers. And it just depends on your class, depends on the teacher, depends on the homework assignment. For our possible answers, we could have gotten that original decimal of 0.3. Decimals are fine. Some of the homework questions are going to want decimals. Or we could have stuck with that 3/10. That's a fraction. We have fractions in probability all the time. Or we can come back and take this decimal, move this 2 over to get a percentage. So which answer do we want for these questions? It's up to you. You'll see in the multiple choice for the quizzes that everything will be a decimal, or everything will be a fraction, or everything will be a percent. It's not meant to trick you. We don't want you to wonder how to answer. So just look at the multiple choice answers to see if things are in decimals or things are in fractions. Again, all of these are correct, but we're just going to choose one way to answer our questions. Okay. That's our example. We've got 3 more examples to go. A real quick hint, though, for these homework questions is in some of the homework questions, it'll say that you have like 12 brown M&Ms and you have 10 green M&Ms and 4 blue and so on. It won't tell you how many M&Ms you have total. Like this one said we have 20, right? So how would we figure out total M&Ms for this to get that bottom number here? We would just have to add all these up by hand. So to get that bottom number, just add up all those different candies. Okay, let's move on to our last 3 examples. We've got 3 more examples to go. They all have to do with games that we're playing. We love probability with games. Chances are you're rolling a dice, you don't know what's going to come up. You're pulling a card out of a pile, you don't know what's going to happen. You've got little spinners like for Twister or something like that, and our little spinner lands on something. All of these have to do with probability. We can study probability with them. Let's go ahead and study our dice first. Example number 2 has to do with the dice. Dice is plural. A single one is called die. Not something we love saying. That's okay. If you have a dice or if you have a die, we can say it either way. There's a 1, 2, 3, 4, 5, or 6 on the dice. So only 6 different options. 1, 2, 3, 4, 5, 6 is our sample space. And an event would be, do we want to roll a 3? Do we want to roll a 6? Let's see what happens. So let's bring in our notation for probability. What's the probability of rolling a 4? Again, this is what we want to happen over what can or could happen. What do we want? We want to roll a 4. I'm not going to write a 4 here. I want to think about it. I want to roll a 4. How many of these are 4s? Just this one. So there's 1 4 on a dice. That's what I want. I want to get that 1 4. Out of what could happen. How many different numbers could pop up? 6 different numbers. There it is, 1 6. And we'll just keep it as a fraction. Sometimes we love these fractions because we just get to stop early. We don't have to calculate a decimal. Okay. How about the probability of rolling an even number? Okay. Once again, let's just focus on what do we want to happen over what can happen. How many even numbers are there up here? This guy's even, this guy's even, this guy's even. There are 3 even numbers that I would want to get. Over what can happen, we can start to see over and over again. We're going to get 6 on the bottom of all of these problems. Does this reduce? Yes. Do you have to reduce it? Yes. There it is. 1/2. Okay. One more example here. We're going to do the probability of rolling a dice and not getting a 6. Let's say you're playing a game and you just don't want to get a 6. So what do we want? What can happen here? We want to not get a 6. So we don't want a 6. How many of these are not 6s? Not a 6, not a 6, not a 6, not a 6, not a 6. There are 5 non-6 options. Again, we keep that 6 on the bottom of what could happen. And that's it. So there's our probability with dice. We can also have probability with cards. Not a lot of people are playing with a lot of standard decks of cards. I've noticed this. Maybe you play like Uno or something like that with a different deck of cards. But what we want to study with probability is a standard deck of cards. So a standard deck of cards has 52 cards. And while you're doing your homework and your assessment and everything like that, you can cut back to this video, or you can just come back to your notes here and look at what we wrote down here. So I really want you to write this chart down for cards. There's 26 black cards, and there's 26 red cards. And then in the black cards, you have 13 spades and also 13 clubs. And a spade looks like this little funny guy, and a club looks like a little tree. Okay. In the red cards, we have 13 hearts. That's an easy symbol. There's our hearts. Or we can have 13 diamonds. There we go. So those are called suits. That's okay. I just want you to know that we've got spades, clubs, hearts, and diamonds, and there's 13 of each. And then in all of these guys, for all of our spades and all of our clubs, all of our hearts, all of our diamonds, there's an ace of each one. And then there's a 2 and a 3 and a 4. And it counts all the way until we get 4, 5, 6, 8, 9. There's 10s. And then there's a jack, a queen, and a king. So that happens for clubs too. There's an ace of clubs, 2 of clubs, 3 of clubs, 4 of clubs, 5, 6, 7, 8, 9 of clubs. There's a 10 of clubs, jack, queen, king. You can just fill this out. If you don't feel like you need it, that's fine. But like I said, not a lot of students play a lot of cards. Ace, 2, 3, 4. And we can kind of see the ace counts as like a 1. It's either a low card. Sometimes it's a high card. And when you guys are old enough, you can come back to me and talk about how to play some card games in Vegas or something. Okay. Shouldn't talk about that too much. So here's what we know about cards. We've got black cards, red cards. We've got 2 different sets of blacks, 2 different sets of reds. And we've got 4 aces in the deck, 4 2s, 4 3s, 4 4s. It goes to 10, and then we've got jack, queen, king. Okay. If you already know this, that's great. You can hopefully work ahead. But let's just talk about the probability of, in a deck of cards, pulling out a card. So let's say you want to pull a black card. I'm going to write this every time until we get it. What we want out of what we can get. What do we want? We want a black card. How many black cards are there? Come back up here. 26. Out of how many total cards are there in a deck? 52. Can we reduce this? Yes, we can. We can see that this is actually half, or you can use a calculator, math, enter, enter, and get that guy. There's our 1/2. Let's try something else. What if we have a deck of cards and we want to draw a king? How many kings are there in a deck? We can actually see it right here. There's 4 kings. How many total cards can we pull out of the stack, or could we pull out of the stack? Another 52. We're going to reduce that. I'll show my work on this guy if we want to. 4 out of 52. We get a decimal. Probably don't want this decimal. We might on some of the homework. That's fine. There we go, 1/13. So I think on this one, 1/13, or let's put the decimal. I mean, just in case we wanted it, I'll kind of round that to 2 decimal spots. I won't put the percentage. That's fine. Let's try it again. Last one for cards. Let's say we want the probability of pulling a heart out of the deck. Again, just our basic formula. What do we want? We want a heart. How many hearts are there? Coming up to our chart here, there's 13 hearts. How many total cards? 52. If you reduce that fraction, you get 1/4, which is a great answer. Or if they want decimals, we could get that one too. Okay, that's it for playing cards. Our last example has to do with a spinner. We've got some homework questions with spinners, so I want to make sure that we can do this. Here's our last example, example 4. We've got a spinner. That's a great looking circle. Okay, so I'm going to cut this guy into 6 different pieces, and we're going to pretend they're all sorts of different colors. This is a blue, this is a yellow. Maybe we're playing Twister and it's like right hand red or right hand blue. I'm just going to put lots of colors on here. Green, maybe there's another red piece down here, another green piece here. And imagine, if you would, that there's like a little spinner or something like that, and you would go like that and it would zing all the way around. Oh, there's our little guy. How many different sections are there? That's 6. So that's going to be our sample space. And I can just ask you whatever we want. What's the probability of getting a blue? How many of these little guys are blue if I go to spin it? There's 1 blue. And how many places could it land? 6. Easy. Love it. What's the probability of getting a red? How many of these guys are red? I see 2 reds. Out of how many total? 6. Do we have to reduce that? You betcha. 1/3. Last question, and it's not a trick question. It's just something to think about. Sometimes probabilities are 0. They don't make much sense. What's the probability of getting a purple? What do we want to happen? We want to get a purple. How many of these are purple? 0. Out of how many total? 6. 0 divided by anything is 0. Sometimes probabilities are 0, and that's fine. It's not, again, not a trick question. So there's our intro to probability. I hope it makes a lot of sense. There's other videos you can find online if you're just still not feeling it on YouTube. Again, if you're stuck, ask your teacher, ask a friend. They'll help you out. Okay, guys, good luck with the homework.